The economics of nuclear in the long term are very, very good. These are plants that, were originally the existing 400 or so plants in the around the world were originally designed for 40-year design life, are now being extended to 60 to 80 years. And some are even saying that they will last 100 years long.
Welcome to Sustainability Leaders. I'm Michael Torrance, Chief Sustainability Officer at BMO. On this show, we will talk with leading sustainability practitioners from the corporate, investor, academic, and NGO communities to explore how this rapidly evolving field of sustainability is impacting global investment, business practices, and our world.
The views expressed here are those of the participants and not those of Bank of Montreal, its affiliates, or subsidiaries.
Hi, Jayen Veerapen. I'm a senior advisor with BMO Climate Institute. The notion of a nuclear renaissance gained much traction in the early 2000s before experiencing a prolonged lull over the past, let's say, 10 plus years. Today, nuclear renaissance is experiencing its own renaissance. Why and what's different this time around? Today's guest, Chris Levesque, is the president and CEO of TerraPower, a company which, in its own words, was founded by visionaries that decided the private sector needed to take action in developing advanced nuclear energy to meet growing electricity needs, mitigate climate change, and lift billions out of poverty. Today, drawing on his decades of experience in the nuclear industry, Chris will help us understand the new nuclear renaissance and TerraPower's innovations and path to commercialization. Chris, welcome to the show, and thank you so much for being here today.
Thanks for having me, Jayen.
So, Chris, would you please introduce yourself and TerraPower, the company you've been leading since 2018 after joining in 2015?
I've worked my whole career in nuclear energy, beginning as a submarine officer in the U.S. Navy. I've worked in several of the large American and French nuclear engineering firms that focused on the existing light water reactor technology. 10 years ago, I had the chance to come and join Bill Gates at TerraPower. And, Bill created TerraPower because he recognized that the nuclear industry wasn't really the most innovative industry going. It was very focused on safety and reliability, which was important. But because the industry was so focused on compliance, raising capacity factors and things, it was also an industry that didn't really allow for innovation. And so it's been a great experience joining Bill and all of our great scientists here at TerraPower, where we've developed a new reactor called Natrium, which turns out is the next American reactor to go online in 2030.
Thanks for these explanations, Chris. And just a little bit of history. I think it's always interesting to know where we have been, learn from, what's happened in the past few years. And as we look forward to this new nuclear renaissance, I remember in the early 2000s, I was working for a nuclear fuel producer. Nuclear renaissance was instilling a good deal of optimism in the nuclear industry. In a way, here we go again 20 years later, there's much talk of a nuclear renaissance. Can you help us understand the wider context within which nuclear energy fits currently and why this time around things are different?
I think it's worth recognizing to start that nuclear energy is very highly valued. There's 400 nuclear power plants around the world that have been operating safely, 94 in the U.S. It's emission-free energy. In the U.S., it's accounting for 20% of our electricity generation. In France, it's more like 80%. And plants that are running today around the world are seen as safe and very, very valuable. But it's also true that especially in the free world, outside Russia and China, it's true that we've had trouble sustaining new builds. The centrally planned economies like China, they've really shown that having nuclear in the portfolio is important. That's why they have dozens of new builds. And also because they're centrally planned, they can kind of manage these 10 plus year long projects. But in our economies, we have a kind of impatience for projects that long. And that's why we've struggled with some of the new builds. I think that's a big reason why we need to move to advanced technology like Natrium. Natrium, because it's a low pressure plant, will need far less concrete and steel. It'll be a lighter plant than today's reactors that can be built more like on a schedule of, similar to maybe a combined cycle gas plant. You asked too about what we thought was a nuclear renaissance around 2005, 6, 7, and, what happened there. I think at that time we were, in earnest working towards a new wave of new builds in the US and Europe. But two things that hampered that were one was fracking development. So all of a sudden in the US, natural gas prices, really dropped. And again, made this existing nuclear technology unaffordable, really, at least in the US. In other countries, not all countries have cheap gas like the US does, but beyond the economics, the other thing that happened in that time frame was, the Fukushima earthquake. And even though, there were no deaths or serious injuries associated with the accident at Fukushima, it did cause kind of renewed concerns about nuclear energy safety.
And I think, Chris, in terms of just the sheer demand in electricity, things have changed quite a bit since 20 years ago. When you look at just the demand forecast for electricity from AI and data centers, the forecasts are really exponential use requirement for electricity. Is it fair to say that AI and data centers are shaping up to be huge drivers for electricity worldwide and by extension for nuclear?
Absolutely. And I'll get to data centers, but even before data centers, electrification is happening as driven by the climate movement. You can see, transportation, electric vehicles, electric buses, moving from fossil fuels to electricity. You can see various industries moving towards electrification with like developments in clean steel, for example, that won't be as carbon intensive, but they will be electricity intensive. So even before data centers, the electrification movement and kind of a necessary catch up in, investing in the electricity supply are causing a great demand. Now bring on AI, together we're seeing those factors combine for what, we believe will be something like a tripling of electricity demand in developed economies between now and 2050.
So today, if you don't capture carbon emissions from a fossil fuel power plant, there are two main carbon-free options available: renewables with storage. And there are also a lot of developments in energy storage. And the other is nuclear. Can nuclear and renewables exist side by side? Is a nuclear renaissance compatible with a large build-out of renewable capacity?
Absolutely. Nuclear and wind and solar and the storage technologies that are under development are all going to be necessary, both to reduce emissions, but also just to meet the energy needs of our countries. For too long, nuclear energy and renewables kind of competed. And I think you're seeing more and more synergy between the two. And there's multiple studies now that show, MIT's produced some things. Energy Northwest, the utility in Washington State, have produced a study. There's multiple studies now showing that an emission-free grid, really ideally includes, a large amount of renewables, but also something like 20% nuclear. So if you look at, in the US, we're at 20% nuclear today. And then you say, well, demand is going to grow. It's going to triple between now and 2050. That means nuclear should also triple just to keep its 20% share. And one particular thing about Natrium that I'd like to point out is it's very different than today's reactors. As I mentioned, it's low pressure and therefore it's going to be cheaper. But also we have incorporated molten salt energy storage into our plant. So for the first time, we're going to have a nuclear power plant that can rapidly change its power output, during the day when either the demands on the grid change or when, the wind or the solar energy is curtailed, which does happen. So Natrium really complements renewables.
And you mentioned something about costs, and that's a nice segue actually into talk about costs in nuclear in general, and then we will talk about TerraPower's own technology. So just to recap a little bit for our audience, in electricity generation, there is this concept of levelized cost of electricity, LCOE, which without getting too much into details gives like an average cost of producing 1 unit of electricity over the lifetime of a plant before including upfront capital costs, operating costs over the useful lifetime, and of life decommissioning costs. Some argue that nuclear has quite a high LCOE compared to other types of generation. I would be interested to hear your views on this statement for nuclear in general. And then after that, we can get into what you mentioned about TerraPower's feature that actually help with this LCOE. So first about nuclear in general and its levelized cost of electricity. What are your views on, when people say, it's quite high, and, interested to hear your views on this?
The economics of nuclear in the long term are very, very good. These are plants that, were originally the existing 400 or so plants around the world were originally designed for 40-year design life, are now being extended to 60 to 80 years. And some are even saying that they will last 100 years long. That really changes the LCOE math if you think about spreading the CapEx over that time. But when you're at the beginning of a project, it's not going to be credible to say an asset has 100-year life. But those plants are really lasting that long. You're seeing even some plants that were shut down in the U.S. restarted. So if you see an adverse LCOE for nuclear, that's one thing that changes things when you realize that in actuality these plants live a very long time. Another thing contributing to higher LCOEs right now is we've had an underinvestment in the nuclear fuel supply. Russia was dumping nuclear fuel in the U.S. for quite a while, and that was taken advantage of by utilities who bought the low-cost fuel. But that lack of investment kind of resulted in not enough capacity in the U.S. We now have a shortage of nuclear fuel, so there's an urgent need to invest in the fuel supply in the U.S. and Europe. Increasing capacity will lower the fuel component of LCOE. So there's a few things there, that make nuclear look better if you look closer. But it is true that the CapEx of today's nuclear plants is too high, right? And there's the memories from the 70s and 80s of multiple utilities going bankrupt and having, big impacts on ratepayers' electricity bills when their utilities built nuclear. So we have to think about how things could be different this time around. Everyone loves nuclear plants when they're done, right? But getting through the build is the hard part. And for us, the solution is a few things. We absolutely have to move to advanced technology, right? Bill Gates and our other investors and the DOE are investing in our technology. We have a lot of, first of a kind costs to cover. And the thing that motivates us to make that investment is we know that the final plant design will produce power safely. It will have this built-in energy storage, which will make it have very valuable electricity because it can it can boost its output when wind and solar are curtailed. But also because it will have less steel, less concrete, less labor, we know it should be cheaper and faster to build.
And Chris, can you briefly tell us a little bit about what are these technical features that make a Natrium plant requiring less steel, less concrete, and why is that the case?
So Natrium, the name of our reactor, if you remember from high school chemistry, the symbol for sodium on the periodic table is Na, which is, Latin word for sodium is natrium. Our reactor is, powered by uranium nuclear fuel, uranium-235. So same as today's, operating reactors. We generate a lot of heat by designing a reactor that fissions uranium, and just like today's reactors. But instead of pumping water through the reactor, we pump liquid metal sodium through the reactor. Turns out that, water's a great coolant, but water in today's plants, water boils at a very low temperature, right? 100 degrees centigrade. And that is well below the operating temperature of today's reactors, which operate at about 300 C. So if we want water to stay in its liquid form for cooling in that reactor, we have to have the reactor operate at very high pressures. And so today's reactors are high pressure systems. These plants are really monuments. They'll last a very long time, but there's almost nothing in the world more capital intensive than today's nuclear power plant technology. So when we move to a coolant like sodium, our sodium reactor operates at 500 centigrade, and the boiling temperature of sodium is 900 centigrade. So we're operating the reactor 400 C below boiling. And what that means is you have the reactor, putting out vast amounts of fission heat, but the coolant is at atmospheric pressure. And what that allows us to do is have lighter piping systems, lighter reactor vessel. And we have a very strong safety case, which has, been recognized by the Nuclear Regulatory Commission, that says we do not need to enclose the reactor in a high pressure containment because we don't have a high pressure. In fact, we also locate the reactor below grade. So, concerns like airplane crash resistance and things like that don't require us to build a building that can withstand airplane crash because we locate the reactor below ground.
Thank you for these explanations, Chris. So the sodium as a coolant is a key feature of your technology there with multiple advantages. And one of them is actually, you mentioned safety. And when we talk about nuclear, there are two elephants in the room, safety and waste. I just wanted to have a brief conversation with you on each of these. First, on safety, the nuclear industry, unlike most other sectors, if you have one safety incident anywhere in the world, it has impacts on the whole industry, not just that company involved. So can you tell us how is the nuclear industry collectively has developed and is developing new reactor designs that are inherently safe?
I can tell you a really simple definition of nuclear reactor safety that you don't need to be a nuclear engineer to understand. When we design a reactor in our industry, we look for the 3 C's, all right, which are containment. How do you contain the nuclear material? Cooling, how do you cool the reactor, both during its operation, but also after shutdown? Even after the fission stops, reactors give off a small amount of heat that needs to be removed. And then the last thing is control. How do you control the fission output of the reactor? So today's reactors, again, are very safe. Fission reactors all have a fail-safe mechanism called a SCRAM. And SCRAM stands for an old term, Safety Control Rod Axeman, okay? And the idea is above a reactor, you have control rods, and these rods are made out of material that absorbs neutrons. And if you have any problem at all, the rods are unlatched and you allow gravity to drop these control rods into the reactor. And it's virtually foolproof.
The other aspect, people have in mind, let's just address this and interested to see your point of view on that. So on the waste side, how much waste are we talking about? And where are we on developing a long-term solution, you would say, on the waste within nuclear industry?
I'll get to waste. I should have made one more point about safety too. If we're going to deploy hundreds, if not thousands of reactors around the world to nations who don't even have nuclear today, we need it to be the safest, most advanced technology. So today's reactors are safe. Gen 4 reactors will probabilistically be something like, 100 to 1,000 times safer. So I did want to make that point. Now, moving to waste, what is waste? Waste is the used nuclear fuel, right? We have fresh uranium fuel we load reactors with. And then when the plants are refueled every 2 years, we remove used fuel, which contains the fission products, we call it. Uranium has split in half into fission products, which are highly radioactive. There's no getting around that. That waste needs to be carefully handled. It needs to be enclosed in sealed containers that both contain the used nuclear fuel, but also shield the radiation from those who might be around it. That's been proven quite effectively to be safe. These used fuel containers are, very well developed technology. The other thing, and you alluded to this, is the volume. The volume of waste is actually quite low. If you think about, the almost 100 nuclear reactors in the US providing 20% of electricity for the last, almost 50 years, the entire used fuel waste stream could fit on a football field, maybe 10 meters high. So is it hazardous? For sure. It needs to be carefully managed, but it's also a very, very low volume. And if you were to compare that to the CO2 emissions that would be created by that fossil fuel, there's really no comparison. So then the answer is, what do you do with this low volume of very hazardous used fuel? We believe the best thing to do with it is dispose of it geologically. There's been a lot of work. Finland is really providing leadership here. Finland has built their geologic disposal repository for their used fuel. It's proven that, with the right geology, you can dispose of used fuel in this way. The U.S. should follow suit with Finland.
Let's pivot a little bit now, Chris, to TerraPower itself and its reactor. I understand TerraPower is building its first reactor near a retiring coal facility in Wyoming. First, could you please understand where this reactor fits within your plans toward building a full-size reactor, and what do you want to achieve with that construction that you've started in Wyoming?
TerraPower is still a fairly young nuclear company. We're 18 years old, which is young for nuclear, but old for a startup. And as a young nuclear company, we find ourselves in charge of building, America's next nuclear power station. It's a fact that the next commercial nuclear power station in the U.S. will be Kemmerer Unit 1 in the state of Wyoming. We're building it just down the road from a 60-year-old coal plant that is approaching retirement. The importance of that project is immense because, we're very confident in the technology, but again, especially in the US and Europe, there's not a strong history of successful nuclear new builds. We're very confident in our technology, but we need to show the world this technology is ready. Aside from showing the world the technology is ready, we need to show the world that nuclear projects can be conducted on cost and on schedule.
And, one of the questions around nuclear, and I think it's a positive one, actually, it's around supply chain and value chain. So a nuclear plant, you have a lot of suppliers around it to supply the components. And what's your strategy on supply and value chains?
Really one of the challenges with this expected wave of nuclear new builds is we haven't been building, in the US and Europe, especially China and Russia are. So our supply chain has been somewhat dormant. So we need to reactivate it. And so what that means for TerraPower, when we placed these first orders for our pumps, our heat exchangers, and other equipment for Kemmerer Unit 1, when we place those first purchase orders with all of those suppliers, we're at the same time saying, okay, give us this component to meet our 2030 schedule. But now let's talk about how do we do 2 components per year? And then by middle of 2030s, 5 per year. By end of 2030s, 10 per year. So, there will need to be an investment in manufacturing capacity at all these suppliers. With TerraPower's investors are behind this, trying to make sure we can catalyze the supply chain at the same time.
Looks like you're making good progress, Chris, on the technology itself, on the construction on your first unit. Can you give us some insights into your commercialization strategy? For example, do you have any specific geographical focus, or are you focus more US, North America, world? And yeah, in general, what's your commercialization strategy?
For sure, it's global. When Bill Gates created the company, he was motivated by growing population, by still having energy poverty in some regions. So we still have a vision of supplying nuclear energy all around the world. It will be a phased process, though. And for us, the first phase is demonstrating the first reactor in Wyoming. We expect to have several other U.S. projects going soon. And then I think kind of the phase two will be global, but it will be in nations that already have nuclear energy, where there's existing regulatory frameworks. We spend time in Europe and in Asia. I think, nations like UK, France, Korea, Japan are all prime areas for that next phase of deployment of natrium. But for sure, we're seeing, again, this region where we have the growing populations, right? Africa, Indonesia, India already has nuclear energy, but we have a good dialogue in India with, when natrium might be deployed there. So, for sure, we expect to have hundreds of natrium reactors around the world. We expect, the natrium technology really to be transformational this century in powering the planet.
Thank you, Chris, and we look forward to continuing to follow TerraPower's journey. Have a good day. Thank you.
Thank you. Thanks for your interest and the great discussion. I enjoyed it today.
Thanks for listening to Sustainability Leaders. This podcast is presented by BMO. You can find our show on Apple Podcasts, Spotify, or your favorite podcast player. Press the follow button if you want to get notified when new episodes are published. We value your input, so please leave a rating, review, and any feedback that you might have, or visit us at bmo.com/sustainability leaders. Our show and resources are produced with support from BMO's marketing team and Puddle Creative. Until next time, thanks for listening and have a great week.
For BMO disclosures, please visit bmocm.com/podcast/disclaimer.